Hi everyone. Hello, hello. I think you can hear me. Can you hear me all? Just say yes in the chat if you all can hear me. Just respond in the chat if you can hear me. Okay. Yes. Okay. So let's begin. So hi everyone. My name is Pradyumn Kejriwal, and today we will discuss the solutions to the CF round 1030. I think, right? And 1030, right? Yeah. So we will discuss the problems from A to D1. But before that, I will tell you about our CP courses. All right. So just 1 minute. Yeah. So as you can see on our website on TLE Eliminators.com, you can see that there are 4 levels of courses. And if you are someone who is stuck at just solving one or two problems for a contest, then these courses are for you. They are self-paced courses. We have structured these courses into 4 levels so that you can start from wherever you are: beginner, pre intermediate, intermediate, or advanced. You will learn the most relevant CP concepts through recorded lectures by experienced educators, followed by carefully curated practice problems, combined with hints and detailed solutions that help you understand the why and not just the how. We believe in helping you build the real intuition. If you need more help, then you can get instant doubt supports from higher ed mentors, as you can see here, and so you are never left stuck. Okay. And beyond learning, you'll enjoy leaderboards, gamified progress tracking, internal contests, and PCDs to keep you motivated and consistent. Pick the level that fits your goals and start learning today. And if you are not sure which level you should take, then you can look at the syllabus for that level and the previous levels, so you can judge. And also you can look at the this video, which will tell you how to choose the level. All right, and you can even choose at the course, like you can even look at the course specific, I mean the level specific video about the course, right? So anyways, let's start the PCD now. So yeah, today's first problem was this one: equal subsequences. We call a bit string perfect if it has same number of 101 and 0 in the subsequences. Construct a perfect string of length n where the number of 1 characters it contains is exactly k. Okay, so the problem is very simple to state. Like what I'm saying is that the problem is very simple. So like basically the problem says that we have been given two integers n and k. Okay, and we have to print a bit string. Bit string means any string which contains only 0 or 1, right? So you have to print a bit string which contains only 0 and 1. So it should contain at exactly one, like k ones. There should be k ones, and we have to print such that subsequences 101 and 010 are equal. Okay, so 101 and 010 are equal subsequences. And subsequences what? Basically, let's say you have a binary string 11011. Okay, then in this case, you have, let's say, this subsequence of 101. So one subsequence, then this one as well. All right, so two subsequences. Then you also have this one, so three subsequences, and finally you have this one as well. So four you have of 101. So of 101 you have four, right? And what about 010? So 010 you don't have anything because there's only 10 in this, and to have 010 you need at least two zeros, right? So in samples, if we see that, let's say n and k are 4 and 2. Okay, so 4 and 2 means there should be two ones and two zeros. So what they have printed is 1010, right? So what we have here is that only 101 subsequence and only one this subsequence 0 1 0. So therefore the number of 101 is equal to number of 0 1 0. So this string is like beautiful, or whatever defined. Perfect, it is perfect. Okay. So in 5 comma 3 we have 1 0 1 1 0, 1 0 1 1 0, right? They have printed this. So in this case also, how many 101 are there? 101 is this one right here, so 1, and also this one, so two 101s. And what about 0 1 0? So 0 1 0, this is this one, and also this one, right? So two are there. Okay. So that's what the problem is. We have to print any bit string which contains the same number of 101 and 0 1 0 subsequences. Now the actually this problem is very simple. That is, like, if it strikes you, then it is very simple. Otherwise, you can't solve it. Like, I think basically the main observation here is that there can be zero also. Like, it has to be equal. The number of 101 and 0 1 0 as subsequences should be equal, and it can be zero as well. Like, it is possible that there are zero number of 101 and 0 1 0. Even that, in that case also, it is fine. So if you just print something like 1 1 1 1 1 0 0 0 0 0, so in this string, let's say, how many 101 are there? Zero, right? And how many 0 1 0 are there? Zero. So just if you print this, then it will always work. Like, if you print k ones and n minus k zeros, so it will work, right? It is pretty simple. Okay. So anyone who didn't get this? Solved A in 2 minutes? Yes, I solved in 1 minute. I mean, it was pretty easy, so it doesn't matter actually. As you can see, 1 minute. Anyways, but did not solve more. Okay, that is tragic. It will also work for one baki zero, baki one 1 0 ही होना चाहिए ना? What are you asking, Suraj? It will also work for one baki zero, baki. I don't understand your question. How to increase speed? I'll address these doubts at the end of this PCD. So you make zero of both. Yes, exactly. Any other way? Okay, so Red just told the other way. So he is saying a single one, then some zeros, then all rest ones, then a single zero. Okay, so apparently this also works. So why does this work? Let us think. Like, let's say we have n equals to, or let's say in general case, if we have a single one, then we have some zeros, like some zeros, then we have the rest of the ones, and then we have a single zero, right? So how many 101 are there? How many 101? Basically these number of 101, like this into this, right? So if we have A and B, so if we want 101, then of course we will take this, and we will take 10 from here, and we will take a 1 from here. So if we have A zeros and B ones, then we have A into B number of 101. And what about 0 1 0? So if we want 0 1 0, then obviously we have to take a 0 from here, a 1 from here, and a 0 from here. So again, A into B options for 0 1 0 as well. So therefore it is correct. Yeah, it is nice. That is true. Hmm. I'll address these doubts at the end. Okay. I will tell at the end. Just don't worry about it. All right. So yeah, is A clear to all? Like even this approach works. That you print a single one, then like n minus k minus one zeros. Basically, you want to print n minus k zeros, right? Total. So you will print all but one zeros, then the rest of the ones, and then a single zero. So basically, it would have k minus one into n minus k minus one. These many subsequences of 0 1 0 and 1 0 1, because this is n minus k minus 1 and this is k minus 1. All right. So we'll go to next one. All right. So the next problem was make it permutation. There is a matrix A of size n by n where aij is equal to j for all ij from 1 to n. In one operation, you can select a row and reverse any subarray in it. Find a sequence of at most 2n operations such that every column will contain a permutation of length n. It can be proven that the construction is always possible. If there are multiple solutions, output any of them. Okay, so what they are saying is that we have a matrix of size n by n. Let's say n is equal to 4 for now. So in this case, the matrix looks like 1, 2, 3, 4, then 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, this is the matrix initially. And what we can do is we can select any row. Let's say we select this row and we can select any subarray and reverse it. Okay, let's say I select this and I reverse it, then it will become 3 2 1. It will become what? 3 2 1. Right? So that's what we can do. And I can do something like, let's say I do 3 2 1 here. Then I can reverse this as well. If I reverse this thing, then it will become 4 and 1. 4 and 1. Right? So we can do like this. And like we can do it on multiple rows as well. Right? We can do it on any row at any point in time. So we have to do at most 2n operations and print a sequence which like gives us that every column is a permutation. And permutation means that every column should contain every number from 1 to n, right? So in the samples they have given 3 and 4. So let's see what they have done for 3. So in 3 what they have done is initially it is like this. Then they have reversed this middle row the entirely reversed the middle row, so it becomes 3 to 1. Then what they have done is they have reversed these from here to here, so it becomes 1 comma 2, and then they reverse this in the third row 2 comma 1, and then they reversed this 1 comma 3, so it becomes 3 comma 1. So now as you can see, the finally we have 1 3 2 2 1 3 and 3 2 1. So in every column we have a permutation, which means that it is satisfied. Every column we have um, all the numbers from 1 to n, right? So in general, how do we actually try to solve this? It is like actually pretty simple if you think about it. Okay, so first of all, basically I want that in every column every number should not repeat. Like here, this 1 is repeated. Like in this column, 1 is more than one number of times. Like in some column, like in this column, I want that every number should be only once, right? But here 1 is more than once, right? So not we have to change that somehow, right? So what we can simply do is, let's see, just observe this what I am doing. Let's say initially, like this top row I don't change. Okay, like I am just trying to construct sequence. So let's say I don't change this top row, so it will remain 1 2 3 4. Then I go to second row. Now as you can see, I have this 1 right here. So if I don't change it, there will be two ones in this row and I'll be messed up, right? So I have to change this row. Like specifically, I have to reverse this subarray, or I mean some subarray, such that one is also a part of that subarray. Like I have to definitely reverse this one. So like either do this or do this or do this, right? And you can observe that whatever I do it with, like let's say I go till 2, then this 2 will come right here. Okay, if I go till 3, if I go till 3, then this 3 will come right here. 3, 2, 1, like this, right? Okay. So basically, till wherever you go, that number will come. So let's say for now you go till 2. That means you reverse this subarray 2 comma 1. Okay. And now what to do with this? We will figure out later. Okay. Now let's say we have like we go to this third row. Okay. So again, here 1 cannot come because 1 has already come right here, and also 2 cannot come because 2 is right here. So basically I have to operate on this one, but I cannot end on 2 because in that case 2 will come here and I can't do that. So definitely I have to go till 3. Let's say I go till 3. So in this case it will become like 3, 2, 1, right? And then finally, what about the last row? In the last row I'll have to reverse the entire thing, right? Because I can't have 1 right here, I can't have 2 right here, I can't have 3 right here, I mean here. So I have to have 4, and to have 4 I have to reverse this entire thing. So let's say 4, 3, 2 and 1. Okay. So now what you do, like this column is pretty much done. Okay. And also this column, we have 1, 2 and 3, right? So you want 4 here, you want 4 right here. So what you would do is that you would reverse this one. Okay. Like instead of just writing 1, 2, 3, 4, you will reverse this. Okay. So let's say you reverse this. So 4, 3, 2, right? So now you have this solid as well. Now what you will do, basically what you have done is you have just written this one as it is, and you have reversed this 2, 3, 4 and written it like here, right? Then you have reversed this 1 comma 2, made it 2 comma 1. Now the intuitive next step is to like reverse this. If you reverse this and write here, then it will become 4 comma 3, right? Now what you did, you reversed this thing and wrote it right here, so it became 3, 2, 1. And also you will, let's say you write this right here, 4, and finally you just reverse this entire thing and 4, 3, 2, 1. So there's a little pattern here, a very easy pattern here, that we have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Then we can simply write like we can do this, then we can do this, then we can do like this, and then we can do like this. So what do I mean by that? I can reverse these. Like if I reverse this 2, 3, 4, if I reverse these two, if I reverse these, and if I reverse these, then it will be solved. Okay, so it will become like, when I'm reversing these, then it will become something like this. 1, then 2, 3, 4 I'm reversing, so it will become 4, 3, 2. Then I'm reversing this 2, 1 and 4, 3. Then I reverse this thing, so 3, 2, 1 and 4 right here. And I reverse this, so 4, 3, 2, 1. And as you can see that this entire, like every column is a permutation. Okay. So yeah, that's how you can solve it. So is it somewhat clear, guys? How do I come up with this? Fire tune, I'll like wait for some other people as well. Like if they have some doubt, then they can ask right now. So guys, do you get this? If someone doesn't get it, then just write no in the chat, and I'll ask you what's your doubt. I'll implement. Yeah, I will implement this. General doubts I'll ask. I'll do at the end. Okay. The intuition behind it. See, Anirudh, I did not solve D2. Like I have some ideas, but I did not solve it during the contest, so I can't explain it. Later, you can read the tutorial. Like if you're trying to solve D2, then probably you will get the tutorial as well. What if n is odd? Then also it will work. Like see, what I actually I'll just go over it once more. What I just did here. So I have to convert this into a permutation. So let's say initially this row I just write as it, or like let's say in the first, just look at the first column. Like first of all, I am just trying to make the first column as permutation. Okay. So to do that, let's say I just keep a one here, right? Then in the second row, if I just keep a one here, like directly, then it is wrong because there are two ones in this column now. So I cannot do that. So I have to reverse some subarray, either this subarray or this subarray or this subarray. So let's say I reverse this subarray. So I do 2 comma 1, right? Now I come to this. Now again I need to reverse either this or this or this. But if I reverse this thing, then also 2 will come here. Then this is not cool. So what we will do is we will reverse this subarray, 3 2 1, and then when we come to this row, we will reverse this entire row. So 4 3 2 1, right? And what about the remaining elements like this 2 3 4? If I reverse it, so it becomes 4 3 2, and this 2 1 I have already placed right here, and so 3 4, if I reverse it, it becomes 4 3, and this 4 I'll just place it directly, right? So as you can see in the ith row, what I have done is, like my operations look like this. Basically, um, in this first row, you can say that I reverse this 1 to 1 and 2 to 4. Then in second row, you can say that I reverse this 1 to 2 and 3 to 4. Then in third row, you can say I reversed this 1 2 and 3 and 4 to 4. Then in fourth row, I just reversed this entire thing. So you can just print that. And if n is odd, then what? 1 2 3, 1 2 3, 1 2 3, right? So in this case also same thing. Like here, you will do it like this and this thing. So it will become like 1 3 2, 2 1 3, and 3 2 1. So you can see that all are there. All right. So this should be fine. And to implement this, we can simply observe that what we are doing for the ith row, like this is the first row, right? So for the first row, I am doing 1 to I. Like for the ith row, I'll print 1 to I and I plus 1 to n. Okay. These two operations for every row. And for the last row, for I equal to n, I'll just print 1 to n. So basically for every row from 1 to n minus 1, I take two operations. So 2 into n minus 1. And for the last row, I take one operation. So we have 2 n minus 1 operations, right? And we can do it. Yeah, I just told the way. Like, what I thought was that since we want that every element is distinct in the right side, then if I keep one here, then I definitely cannot keep one here. So I have to reverse this one. So if I just try with two, so I just kept two here and one here. Now I go to this one, so I can't keep one and two right here. So I have to keep three. So I'll reverse till three, right? That's what I thought about. Like it's just trial and error actually. In constructed problems, it's just trial and error, or basically how far you can think. Like um, if you can just discard the wrong answers in your mind, then you can solve it pretty fast. All right. So, anyways, I'll show the code now. Basically, for the ith row, we have 1 to I and I plus 1 to n, right? So, int n c in n, say out 2, 2n minus 1, the number of operations. And for int I equal to 1, I less than equal to n, I plus plus. See out I means the ith row. Like in the output format, we have to print the row, the left and the right. Like till from where to where we want to reverse, and in which row. This is the row. So for the ith row, we have to print from 1 to I, reverse from 1 to I. And for the like, and also in the ith row, we want to print I plus 1 to n. But for the last row, we don't want to print this. So if I is not equal to n, then only we print this operation. So it will print something like this. Like if I just try to run it on here, it will print correctly. Let's say, hmm, wait, yeah. So for example, for 3, it prints 5. Then it prints in the first row 1 to 1 and 2 to 3. Then second row 1 to 2 and 3 to 3. And third row 1 to 3. Right. And for the 4 also, you can see at 1 to 1, 2 to 4. Then 1 to 2, 3 to 4. 1 to 3, 4 to 4. And 1 to 4. Actually, this 4 to 4 and 1 to 1, this is not required, because of course reversing a single element doesn't really do much. So you can skip that as well, but that will take more code. So I just printed them. It is no problem. All right. So let's move on now to problem C. If you want, everyone just say a yes. Why print 2n minus 1? Will it ever change for n? I am printing the number of operations. Like in the output format, it is asking that how many operations you will do. Like if this loads, yeah. So in the output, on the first line, print an integer k, the operations you used to perform, like their number. So since for n, I am doing these many operations, I print this. No, you can, yeah, like in my algorithm, like what I am printing here, as you can see, for 3, it printed 7 operations. Sorry, 5. For 3, it printed 5 operations. So I printed 5. Like, okay, yeah, you can do it in less also, because uh, this operation 1 to 1 is just useless, right? Like, reversing from 1 to 1 is just useless. Reversing one element doesn't make sense at all. Like you can do it, but it doesn't have any useful work. And this 3 to 3 as well, you can skip this. So you can skip these two operations, and it will be done in even lesser. It can be done in 2n minus 3 operations. 2n minus 3 operations, it can be done. But they asked that in at most 2n, like you can do any operation up to 2n. So I just printed 2n minus 1 operations, because that printing 2n minus 3 just takes up more code. Like printing 2n minus 1 operations is less code, right? So yeah, can't we reverse your steps like last operation on the first row? Yeah, we can do that. Okay, I think it is clear to all. So I'll move on to C now. All right. So C, make it beautiful. You are given an array A of n integers. We define the beauty of a number x to be the number of 1 bits in its binary representation. We define the beauty of an array to be the sum of beauties of the numbers it contains. In one operation, you can select an index I and increase ai by 1. Find the maximum beauty of the array after doing at most k operations. Okay, so what they are asking is they have defined a beauty. So beauty of a number they have defined. Beauty means number of 1 bits of a number, right? This is beauty of a number. Beauty of a number is the number of 1 bits in that number. So and they've defined beauty, BEAUTY, right? Beauty of an array, as the sum of beauty of its elements, sum of beauties of the numbers, right? So essentially, you just have the beauty of an array is just equal to the number of ones in the array, like the number of 1 bits in the entire array. So like if you have 01724, this is the array you have 01724. So here in binary it is like 0 1 1 1 1 1 0 and 100, right? So here the beauty of this is 6, because we have 1, then 3 4, then 5 and 6, right? So we have 6 ones in the array, so the beauty is 6. Now what we can do is we can increment any element by 1. In one operation we can increment any element by 1, right? And we can, like, we have to find the maximum beauty of the array after doing at most k operations. Okay, so we have to find the maximum beauty of the array after doing at most k operations. So let's say in the samples we have 5 comma 2, so 5 comma 2 and 01724. So basically we can increase any elements by 2, right? So let's say we have this. So let's say I increase this one, like let's say I increase this, so it becomes 1, right? So this is one operation, and I also increase this one, so it becomes 2 operations, like, okay. So now how many ones we have? We have 1 2 3 4 5 6 7 8. We have 8 ones, and that's the maximum that we can do. So therefore the answer is 8 to this. Okay, so yeah, that's the problem. And here the constraints on n is just 5000, although I solved it in like n log n, so I don't know why it is 5000, but okay. Anyways, so yeah, how do I actually solve this? Let us just think about that. Now guys, I will keep this a bit interactive. Okay, so I have a question for you guys. All right, like what my question is that, let's say I give you this number, 13. All right, so 13 is what? 13 is 1 1 0 1, right? Yeah, it is 1101. So currently it has three active bits. Okay. Let's just keep one this number. So what is this number? This number is basically 32 plus 13, so 45. 45, let's take 45. So this is the number which has four set bits, four bits which are 1. Okay. Now if I ask you that, guys, just tell me that how many times do I have to increase this number? Like in one operation, what can I do? I can do a number a of I plus plus, right? So just, guys, just tell me that at least how many times do I need to increment this number to make the number of set bits to 5. So at least how many times do I have to increment this to make it 5? Just tell me that. 2 times. Okay, how did you guys predict my question? Okay, yeah, 2 times. So we have to increase it 2 times. Why? Because if we do that, then it will be like 1 0 1 1 1 1. So it will have 5 bits set as 1, right? Now from here, let's say I ask you that, let's say I want to make this number have 6 set bits. Then how many operations do you need? Tell me that. Plus 16. Yeah, plus 16. Why? Because if we add 16 to this, 16 is this thing, right? So we add 116 times, or basically if we add 16, then it becomes this 1 1 1 1 1. So this one has 6 significant digits, right? So essentially, what we have here is that, let's say we have a number, any arbitrary binary digit I give you. Okay. Then if I ask you that if you want to increase the number of bits in this number by 1, like currently if it is x, the number of bits where x is 1 2 3 4 5. So currently if it is x is equal to 5, currently if it is x, and if you want to make the number of set bits in it to be x plus 1, then how many operations do you need? It is basically just like you will set this first unset bit to 1. Like simply what you can do is, see here, this one is 0, right? So okay, how do I explain this? Let me just think about it. So see, initially we have just 5. Okay, 1 2 3 4 5. Now we want another one to increase, right? Just 1 minute. Yeah, so initially you have 5 ones, and now you want to have 6. That means you want to increase a 1, right? So the best way to do that is to do what? Like we have these many zeros, right? So we will change one of these zeros to a 1. So let's say if I change this 0 to a 1, then how many times do I need to add? Like essentially I need to add this number, right? 1000. So I'll have to add 8. So I'll need 8 operations to make the number of set bits equal to 6 if I change this. But instead, if I change this bit to 1, then what do I need to add? I need to add just 10. So 10 means 2. So I just need to add 2 to my this number to make it have 6 set bits. So essentially, if we want x plus 1 set bits and currently we have x, then we will just set the lowest 0 bit. Like here the lowest 0 bit is this one, right? 2 to the power 1's bit. It is the lowest unset bit or lowest 0 bit, and we will set it to 1, and that will take how many operations? That will take like 2 to the power k operations, where it is the kth bit. I mean, if it is the kth bit, then it will take, or 2 to the power b, let's say. If it is the bth bit, then it will take 2 to the power b operations. Is it clear, guys? Like here, I'll give one more example. Like here, if we want to make this as 6 significant bits, if we want to make this number have 6 number of ones, sorry, 6 number of ones. If it is currently 5, then we will make this bit as 1, and so we'll add 16. So since this is 2 to the power 4th bit, we will need 2 to the power 4 operations. That is 16 operations we will need, right? Yes, we can increase one when we get even. Yeah, if we increase one, if we have even, then it will increase by 1. That is true. Okay. So, what we can, so okay, now what to do? Now let's see a test case. Let's just see this test case. It will be very simple. All right. So let's say I have 01724. So this means this array is basically 0, 0, 0, 0, 0, 1, 1, 1, 1, or let's just write 4 digits: 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 1, 1, 0, 0, 1, 0, and 0, 1, 0, 0. Okay, this is your array, and your k is equal to 2, right? That means you can do 2 operations to this. Okay, so all right, now in a single number, we saw that the minimum operations that you need to do to increase the number of ones that it has is 2 to the power b, where b is the lowest unset bit. So here, if you want to make this have one more one, then you will have one operation. Like it will take one operation to do that. Now, if you want to increase this number of ones, then it takes 2 operations, 2 to the power 1, right? If you want to increase this number, then it will take how many? 8 operations, right? Then if you want to increase, man, why this eraser doesn't work? Like if I click this, it is not allowing me to select. Why? I don't know. But if I restart it, it makes it work. So why is it that? Anyways, we'll deal with it. So yeah, if you want to increase this number, then you have to do 8 operations on this. Then if you want to increase this number by 1, then you have to do 1 operation. And if you want to increase the number of bits in this one, then also 1 operation you will do, right? And k equals to 2. That means you can do a total 2 operations. Okay. And you have this data with you, that if you increment this number by 1, like you need to increment this number just a single time to get one more bit set. Like these numbers are what? These numbers are the minimum operations. The minimum operations to get one more one. Like to increment the number of ones by 1. So if you perform 8 operations or 8 operations here, then it will increment the number of ones by 1. And if you perform just 2 operations on this number, then also it will increase it by 1. So what will you do? Of course, you will just take the minimum one, right? You will take the minimum one. So you have 0, 0, 0, 0. So you'll increase it by 1. Like here, we have 3 ones. So we'll increase it, like increase any one of them by 1. So if we have 3 ones, we can increase any one by 1. So let's say we increase this, the first one. So it is 1 now. So now if we want to increase even one more time this number, then we will have to do two operations on this. Like to make it 0011, we have to do two operations. Okay, so we have this, and our k has decreased by 1 because we did one operation. And now the minimum is 1. So again we can do one operation here and make it 0011, right? And now k is equal to 0. And here the new value of this is 4, right? But it doesn't matter now because our k is 0 now, right? So total number of ones, how many are there? 1, 2, 5, 7, and 8. Okay, so 8 is our answer. This was pretty simple. I'll show on some complicated one. um they haven't given any complicated ones, so let us just do it on this one only. Like, let's just do on this one, assuming that k was equal to 20. Okay, so 01724, 01724. So this is basically 000 001, 111, 010, and 100. So here the values are what? The values are 1, 2, like 8, and we have 1 and 1. And let's say k is equal to 20. Okay, then what will you do? First you will increase this one. So if you increase this one, it will become like 001, right? So it will, the array will become like this, and your k will become 19. Okay, so here the new values are what? 2, 2, 8, 1, and 1, right? Now again you will increase this one and this one also. So I'll just do both at the same time. So yeah, okay, you will increase these two, 011, 101, and their values will what? Like, this value will become 4, this value will become 2. Okay, and you have done two operations, so now k has become 17. Now what will you do? You will pick up these twos, because that is the minimum. So this two, or this two, anyone you can do. I'll just do all three of them because our k is big enough. So if I just make all three of them, increment them by 2, right? So this is what it has become. And our k will decrement by 6 because we have done the three times, two operations three times. So k is equal to 11 now. And the new values, for this one it will become 4, for this one it will become 4, and for this one also. Okay, for this one it will become 8, right? And now we have 4s and 8s. So what we can do is we can do two 4s, right? So we can do this 111 and 111, and now our k becomes equal to 3. And now we cannot do any more. So our answer will just be 3 plus 3 6 plus 3 9 plus 2 11 and plus 3 14. So 14 is the answer. All right. So that's how you can really just do it. What about last test case? Last test case, I mean, the same thing you will do. Then you will get 36. Like here, 0 initially. If we have a 0 initially, so its value is what? 1. That means you can add 1 to increase its number of bits. So if you add 1, it will become 1. And the operations that you have will become what? Here, what is k? Whatever this k is, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you will have 11 nines. So these many operations you will have: 5, 6, 7, 8, 9, 10, 11. So this is your new k. Then for 1, 1 is 0, 1. So the value is 2. Like you have to add 2 to make it 1 1. So now the value is 4, and now the new k is this and 7. So similarly you can do this. The algorithm is same. Rating, let's go to our god C list. It is not yet there, but I think it should be like around 12, 1300, 1000. Okay, I mean, I really don't know because it is pretty easy for me, so I cannot judge whether it is 1000 or 1200 or 1300 because these are pretty much same to me. So I can't comment on that. Sorry. So yeah. Anyways, so what we are going to do is just find the minimum value for increasing and just increase that. And to find the minimum value, what you can simply do is make a set or a priority queue, right? And just find the minimum from that and increase it and update your set. All right. So that's pretty much it about this problem. I'll just show the code. Yeah. So here nk c and nk input an. So I have the initial array a comma n, and I have a set of pair where the first element is the number of operations that I need to do. That is, what is the LSB, like least significant bit, which is 0. And this second one is the just index, like for which index this value is there, right? And I'll just take the input. Okay, I've taken the input here. I'll iterate through the array for int I equal to 0 as an I plus plus. And this is my pointer to find the lowest bit, which is 0. So while the jth bit of AI is 1, I'll do j plus plus. So at this point, the jth bit is 0. It is the first non 1 bit. So I'll insert 2 to the power j, comma I, right? The value and the index. Okay. And then the initial count of the number of ones is like I'll just calculate that in total how many ones do I have in my array. So this function just counts the number of ones in your array element. All right. So I'll just add them up in my ans variable. Now, while k greater than 0, if s dot begin dot first, that means the minimum element in this set. If it is less than equal to k, so if the minimum is less than equal to k, that means we can do it. Like we can increase that element this many number of times. So k will decrease by this much, right? And also our a, like basically what I'm doing here is I'm just um, like when I'm doing the operation, when I'm doing this, I'm just changing the 0 to a 1. So in my array, I am just taking the or with 2 to the power whatever is the lowest bit. So that will just set that bit to 1. Okay, so a of index or equals to the 2 to the power lowest 0 bit, right? And ans plus plus, because the number of ones in our array has increased, then index is equal to this, yeah, the index of current one, and I'll erase it from the set because I want to insert the new value, right? Like this was the old value that was there. So I want to, like, since I made that bit as 1, now I want the new bit which is 0. Like here, if I make this bit as 1, so initially the value was 1, but now the value after making it 0 1 1, it is 4, right? 2 to the power 2. So I want to update the value in the set also. So I'm just erasing the old value and again I am just iterating over the AI. So while the jth bit of a of idx is 1, I'll do j plus plus, and so at this point the jth bit is 0. So I'll do as insert 2 to the power j comma index, right? And yeah, if as begin dot first is greater than k, then we will break because we cannot do any more operations, and finally we'll print the answer. Okay. If we just focus on the setting the bit of every n element, there are, if they're not set, it will not be more easier. Yeah, that is true. The rating, I am not sure. Let's see if it has come now. I don't think it would have come by now. It is not there. I'm not really sure what is the rating. This will also work if we just like keep doing it. For example, in this test case, we have 01724, 0, 1, 7, then 2, and 4. So what they're saying is just first set all the unit digit of all the numbers to 1. Like just make this like this: 001, 001, 111, 011, and 101, right? And then just make the 2 to the power 1's digit of them as 1, and then just make the third digit and so on. Like, yeah, that's true. And like that's what I'm doing also, but I'm just doing it more efficiently. I mean, I'm not iterating over the entire array always. I'm just checking that what is the lowest set bit. So if it is something like, let's say the array is something like 011, 011, then what you will do is you will spend some time checking this bit and then this bit also. But I will directly go to this bit. But actually yours is better because your complexity is O of n into log AI, n into log AI, and mine is O of n log n into log AI. So yeah, yours is better actually. Anyways, what about cheating? Well, we can't do anything about that. Who cheated? Sorry, who cheated? Many people have cheated from ChatGPT. Yes, yours is n log AI. I told that only. Mine is n log n into log AI because I am continuously iterating over, like, from due to this loop. Because of this loop, I have log AI also. Otherwise, it is n log n. Like mine is n log n, but because of this loop, it adds extra log AI to my answer. But actually, no, actually, my bad. It is like, okay, yeah, it is n log AI, n log n log AI. Mine is n log n log AI because this while loop can run n into log AI times, right? Like we can increase. Okay, you are saying it is n log k. Um, n log k. I mean, yeah, okay, yeah, it is n log k essentially. Is it? No, I don't think it's n log k. Like for example, if we have a test case like this: 0, 1, 1, 1, 1, 1, then again 0, 1, 1, 1, 1, 1, 1, and let's say our k is equal to 1. Okay, then you are saying that yours is n into log k, but actually it will depend on how many ones are there. Like these numbers, how big they are. So if they are more big, you will take more iterations, right? Like you will try first this bit for all, then you will try this bit for all numbers. So it is n log AI. Yours is n log AI. We go till k. Ah, right. Sorry. So it is n log k. True, true. Good. Shubham, like we can mostly we can just see the codes. Like in the code, you can just see the loops and how many times they will run. You can guess from that. Anyways, let's go to D now. Enough of discussion on C. Okay. So D1. Yeah. So I had solved D1, but not D2. Okay. So you are given a strip of length 10 to the power 5 and of 10 to the 15 and a constant k. There are exactly n cells that contain a traffic light. Each has a position pi and an initial delay di, for which di is less than k. The ith traffic light works the following way. It shows red at L into k plus di second, where L is an integer, and it shows green otherwise. At second 0, you are initially positioned at some cell on the strip facing the positive direction. At each second, you perform the following actions in order. If the current cell contains a traffic light, you turn around, move one cell in the direction that you are currently facing. You are given q starting positions. For each one, determine whether you will leave the trip within 10 to the power 100 seconds, essentially infinite seconds. Like if you don't leave within this much second, then definitely you are stuck for infinity. Okay. So in this case, the constraints are n and k up to 500. All right. So yeah, what they are saying is that we have a long strip. Okay, we have a long strip of length 10 to the power 15, and on some places we have traffic lights, right? So let's say here we have a traffic light and here we have a traffic light. Okay, and this traffic light as this traffic light has a delay of, let's say, 4, and this one has a delay of 3, and my k is equal to 5. Okay, so k is equal to 5 means that these traffic lights will show every 5 seconds red. Like basically this traffic light will show red at t equals to 4, t equal to 9, t equal to 14, and so on. And this traffic light will show red at t equal to 3, t equal to 4, sorry, t equal to 3, t equal to 8, t equal to 13, and so on. Okay, so what you want to do is that you will start at some position. Okay, you will start somewhere and you will face towards the right. So now, if currently where you are, if the light is red, then you will turn around. Okay, otherwise you will keep in the same direction. Okay, and then you will move one step in whatever direction you are facing. Like they have given examples, so let's see them. So here in the first test case, we have two lights. Like first light is at 1 and second is at 4. So we have two lights right here, this one and this one. Okay, and the first, okay, and k is equal to 2. So time period is 2. So the first light will show red at t equal to 1, t equal to 3, t equal to 5, and so on. And second light will show at t equal to 0, t equal to 2, t equal to 4, and so on. So here we were dropped on the first cell at t equal to 0. Okay, so at t equal to 0, this light is red and this is green. Okay, so since our current position was green, so we went ahead by one step. Okay, so now we are at t equal to 1 and this is red, this is green. Now again, since wherever we are, it is not red. So again we can move ahead. So we moved ahead. All right. And in this case, it is just moving ahead. So I'll just see this case. So here you can see if we start from here, initially this is green, this is red. Now since we wherever we are, we don't have a traffic light, so we can move ahead. So we moved here. Then again we are here, and like we don't have a red light here, so we can move ahead right here. Now we are here, and we are facing the positive direction, right? Like we are facing right. Okay, but now red is here, red light is here, so we have to flip. So we flipped, and we went here. Okay, now this is again not red, so we can move ahead. We moved ahead. Now again this is not red, so we moved here, and this is red. It is now red, so we have to flip. Like we cannot just go outside. Okay, so we flipped, and again we went here, then we went here, then we went here, then again it is red, so we have to flip, and so on it will go. So we cannot actually leave this strip. Like we will keep doing infinite. We will just we are stuck here infinitely for infinite time. Okay, so how do we actually determine this, that whether we can escape or not? Okay, so one thing that you can notice, like there's an observation here, that let's say k is equal to 4. Okay, then the time t equal to 1, time t equal to 1, or time t equal to 5, or time t equal to 9, etc. Like all of these times, they are the same to us. That is, at all of these times, the light configuration, that is red or green, it will be same. Like whatever lights they are red at t equal to 1, only they will be red at t equal to 5 and t equal to 9, and the rest will be green, right? So for all our purposes, these times, like all of these times, are actually equal to us. So if k is equal to 4, then all of these times, 9, 13, 17, 21, they are all the same to us. That means that for us, the time is circular. That is, we start at t equal to 0, then t equal to 1, then t equal to 2, then t equal to 3. Then after 3, we again go to 0. Like our time actually again goes to 0. Like we can think of it like that. Because in reality, we go to t equal to 4. But since 4 is same as 0, if k is equal to 4, I mean, if k is equal to 4, then since 4 is equal to 0, um, we can essentially say that from 3 we can go to 0. Like the time in our world moves like this: 0 1 2 3, 0 1 2 3, and the lights which are on or off depend on this one only. Okay, so whether or not the light is on just depends on this number. Whether, like, what is the current time right now? Okay, so we can do it like that. So essentially, let's say, okay, let's say we have this strip. We have this strip, and I know, like for some reason, I know that if at time t equal to 3, if at time t equal to 3, if I am placed here, then I can escape. Let's say I know this. Okay, let's say I know that if I am placed here at time t equal to 3 and facing the positive direction, facing here, then I can escape. Then if I am placed right here at time t equals to 2 and I am facing here, and the light here is green, let's say. So at t equals to 2, the light is green. And I know that if I were placed here at t equal to 3, then I could escape. Then what can I say? I can say that I can escape from here as well. I can escape from here. Why? Because I know that I can escape from here. So I can go from here to here. So if I'm at time t equal to 2 here, I will be at time t equal to 3 here. Right? And so I'll escape. Okay. Is it clear, guys? This part is clear? N into k into 4 dp. Yes. Like, not really dp. Like it is kind of like BFS. Honey Singh, which code? I showed you the code of C. Lovia Jain, it can be solved using, yeah, like not really DP, but BFS or something. So like, I'll discuss it. So as you can see that if I know that if someone puts me at time t equal to 2 right here, then I'll escape. Given that I can escape from this thing. So essentially, it is recursive, right? Like, see, what can I say? For example, if I know that there's a light right here, there's a light right, or let's just see the test case. Like this test case, let's see. We have a strip where we have a light at position 1. Okay, and for it the delay is 1. That is it will glow up at time t equal to 1, and for us k equal to 2. And we have this light which glows up at t equal to 0. Okay, so we have two lights, one which shows red at t equal to 1, and one which shows red at t equal to 0. All right. So initially t equal to 0, right? And for us time goes like 0 1, then again 0 again 1, then again 0 again 1, because k is 2. Okay, so now if I know, like let's say if I am placed here facing the left direction, okay, then definitely I can escape, right? I can escape if I am placed here at t equal to 0. At t equal to 0, if I am placed here, I can escape. Okay, then let's say if I am placed here at t equal to 0 facing this direction, then can I escape directly? No, because the light will be red at this point, right? Because t is 0, so the light is red, so I'll have to turn. So I will turn and I will reach here after 3 seconds. That is, if I am put at t equal to 0 here, I will go to first this cell at t equal to 1, then this cell at t equal to 0, then this cell at t equal to 1. All right. And when I reach here at t equal to 1, it will be red light, right? It will be red light. So I'll again have to turn. So I'll turn. So at t equal to 1, I was here. Then at t equal to 0, I'll be here. At t equal to 1, I'll be here. And again at t equal to 0, I will reach here facing this direction. So now, essentially, I started with 0 at this direction. Like I started with t equal to 0 and this direction. And again, I have reached the state of 0 and this direction. So basically, I am in a cycle, right? Because I just ended up where what I started with. Okay. So I was here at t equal to 0 facing this direction. And again, I am here at t equal to 0 facing this direction. So definitely, I am stuck in a loop. So if I am here facing this direction at t equal to 0, then I am not able to leave the strip. Okay. So let us just understand for more general strip. Like this one had just two. Let us just explore for more number of strips, let's say. Okay, so let's say I know. Okay, let's say k equal to 3, and there is one light here whose number is 2. like it shows red at 2, 5 and 8. Then there is one light here and it shows red at 1, that is 1, 4, 7 and so on. And there is one light here and it shows red at 0. Okay, and let's say that initially we have been pushed here at t equal to 0. All right, so now the distance between these two is what, like 1, 2, 3, 4 and 5, right? So if I am at t equal to 0 here, when I reach at this point, okay, I am at t equal to 0 facing this direction. So when I reach this point, it will be like what, 1, 2, 0, 1, 2. So I will reach here at t equals to 2. Okay, facing this direction, right? So if I know that what is the answer to this state, like what is the answer if I reach here at t equal to 2 facing this direction, then that's the answer for this one as well. Like if we can escape from this state, then we can escape from this state as well. So basically we have a recursion right here, and in the recursion our parameters are very limited. Like what I can just do is I can write this position answer in terms of this position. Like if I want to find out that can I escape from here, then I can find out that what is the next light bulb, that what is the next light bulb that I will reach, like from here. If I am at t equal to 0 and I start here facing this direction, then next I will reach this light bulb facing this direction at t equal to 2. So if the answer to this state is yes, that means I can escape from this state. So that means that I can escape from this state also. So I have a recursion in terms of the states. And what is my state? Essentially, I only have the position. I mean, not even the position. In my state, I will store that which light bulb, like index of light bulb, essentially. Index of light bulb. Then we have the time and also the direction. If I store the answer for all the possibilities of these three numbers, then I can simply find any answer, because I can write the answer to one in terms of the others. Like I can write the answer to this state in terms of this state, right? But what's the base case right here? The base case is essentially when you are at the end, like either at the first light bulb or at the last light bulb, and you are at this direction. Like let's say if you are at t equal to 0 on this state and having this direction, then it is true. Like this is the base case, right? Because you will escape directly. There's one more case. Let's say you are here. Let's say you are here, okay, facing this direction, but at t equal to 2. So if you are here at t equal to 2 facing this direction, okay, then you will escape, because at this point the light is red, so you will turn around and you will escape, right? But if at t equal to 2 you are facing originally this direction, then the answer is not yes, like it is not a base case. Okay, so we'll have to do recursion. Like if at t equal to 2 you are facing right here, then since the light is red, you will flip, right? You will flip, and then you will reach this one at t equal to 1, right? Like 2 0 1 2 3 0, I mean, sorry, you will reach this state at t equal to, sorry, it is 1 only. You are here at 2, so when you reach here you are at t equal to 0, then t equal to 1, t equal to 2, t equal to 0, and again you will reach here at t equal to 1. right? So if whatever is the answer to this, that is the answer to this. Like it is not the base case. Okay. So we just have a recursion right here, and we can use dp to solve it. But here actually we cannot just do naive dp, like because we have cycles as well, right? Like as we saw here, this state, like what state, let's say this state right here, that we are at the second light bulb facing left and at t equal to 2. So this state depends on this state, right? So if we start here facing left, or basically facing right, then we'll flip and reach here at t equal to 5, or basically at t equal to 1, like modulo 2, right? Because k is 2 in this case. So modulo 2 we reach at t equal to 1. So this t equal to 1 case again depends on this case right here, t equal to 0, and we are at this facing this direction. So we have cycles in our dp graph. Like uh, like what I'm saying is, in normal dp, let's say in fibonacci, we have like fib of n depends on fibonacci of n minus 1 and fibonacci of n minus 2, and then again n minus 1 depends on fibonacci of n minus 2 and fibonacci of n minus 3, and again this fibonacci of n minus 2 depends on this and this. So instead of doing like drawing a tree, what you would do is you would store the values in dp, and it would form like a graph. Basically fib of n would depend on fib of n minus 1, and also fib of n minus 2. It would depend on both of these, and again fib of n minus 1 would depend on fib of n minus 2 and fib of n minus 3, right? So this is what your actual dp looks like, normal dp. But in this case you don't have any cycles. Like here the dependence is not cyclic. Like in this graph you won't find any cycles. This is a dag, basically a dag. But in this case we have cycles. That is, we can go from this state to this state, and again from this state to this state. So there is a problem. Like we can, that's why we cannot just implement dp in the normal way. So what we can do is we can actually just see, like if if we have a cycle, then the answer is no, right? Like um, this state, as you can see, this state depends on this state, and this state depends on this state. So again, like we have a cycle here. So for all nodes in this cycle, the answer is just no, because essentially we are stuck in a cycle, right? So we can just mark them as no. Or a simpler way, what we can do, we can just start a BFS from all the base cases. Like what is the case? Like if I start from here, let's say I start from here at t equal to 0, facing this direction, then I'll just escape immediately. I just escape immediately because the green light is there. The light is green and I am facing the outwards. So the answer is yes for this. Okay. So now what I'll do, that every state which can reach this, okay, every state which can reach this, I will mark them as true again. And then every state which can reach that state, I'll mark that as true as well. So I will just kind of do this BFS kind of thing from all the base cases, and I'll keep marking true until I can't. So essentially I would have a kind of multi-source BFS. Multi-source BFS starting from all the base cases. Okay, and we can simply do that. And because our constraints are pretty low, like how many states do we have actually? Like in our variables, how many? What are the states? So one is the index of light bulb. Like we have n light bulbs, right? So there are n values of this index. Then we have time, and in our world, the time is only modulo k. Like if k is 3, then our time goes like 0, 1, 2, 0, 1, 2, and so on. So our time is just k. The number of possible values for time is k. And the direction, we have two directions, possible directions. So we just have 2 into n into k number of states, right? Or basically 2 into nk number of vertices in our graph. Okay, and we can simply do a bfs on that, and it will solve the problem in O of n into k. So what we are doing is, whatever the base cases are for which the answer is true, we will start a bfs from those nodes and wherever we can reach. So in our graph, we'll have the edges reversed. Like if I can reach from this state to this state, and if this is base case, then I'll mark this as yes. Like if this is yes, and if I can reach from here to here, then of course this is also yes. So basically in my graph, the edge will be from this vertex to this vertex, right? So in my graph, it will be reversed. The edges will be reversed. The edges will be reversed. Okay. So this is what the high level overview of this problem looks like. So do you guys kind of get it? Or should I run it on some test case? Like should I run it on this test case? This small test case. Do you want me to run it on this to understand it better? Or do you get this? Like what I explained right here, that recursively you can solve this. Like if we start from some light bulb, if we start, let's say from this light bulb right here, we have a light bulb here, and we start at t equal to 0, and we go towards this direction. Then if it is green, then I'll just see that which light bulb do I have the next, right? And I will go there, and I will reach there at t equal to something, right? And if the answer to that is yes, like if the answer to that is that I can leave from there, like if I reach here at t equal to, let's say, 1, okay, if I can like leave from there, then definitely I can leave from here as well. So recursively I can solve this problem, and if you just draw the recurrence graph, then you will find that it has some cycles in it, right? So what you can simply do is, whatever the base cases are, you can just run basis from there. Like okay, let me just dry run on this test case to make it more clear. Like I think it might not be clear to some of them, some of you. So okay, we have essentially um, we have one strip which has, it has a light bulb at 1, light bulb at 4, okay, and our k is equal to 2, and this bulb shows red at t equal to 1, and this bulb shows red at t equal to 0, okay. So we have this situation. So let us make a graph for this, okay. So basically our state is what? Our state is index of bulb, then time, then direction. Okay. So this can be either 0 or 1. Like this is the 0th light bulb, this is one light bulb. And this time can be 0 or 1. Right. And direction, it can be either positive or negative. Right. So let's say that we want to find the answer for 0 0 positive. So what does this mean? This means that if we have been transported here at t equal to 0, transported at the 0 light bulb at t equal to 0, facing the positive direction initially, then what is the answer? Okay, so in that case, what we will do? So since t equal to 0 here, that means it is green, because at t equal to 1 it shows red. So currently it is green, right? So we will go here at t equal to 1, then here at t equal to 0, then again here at t equal to 1. So basically, if we start here having these coordinates, then we will reach at this state in the positive direction at t equal to 1, right? So from 0 0 t, we can reach to 1. 1 is the index of this light bulb. Then time is 1, and the direction is also positive. So we can reach from this state to this state, 0 0 plus to 1 1 plus. Okay. Then, as you can see, 1 1 plus. Now let's see about that. So 1 1 plus means at 1 t equal to 1, this light bulb is green, right? So therefore, if we are positive direction, then that means we'll escape. Like it is the base case. This is the base case, and therefore the answer to this is just yes. Like we can directly escape from this vortex. Okay. Wait. Yeah. So this 1 1 plus is a base case. All right. Now, what about the other cases? Let's say we want to see 0 1 plus. 0 1 plus means we are spawned here at t equal to 1 in positive direction. At t equal to positive direction. So since t equal to 1, this bulb is red, right? The bulb is red. So we'll go this side and we will escape this. So essentially, this state also um, a base case. Okay. Then we will have 8 cases, right? We have 8 states right here, because there are 2 indexes and 2 times and 2 directions. So in total we have 8 cases, and I'll just quickly run through them. Then let's say I have what is left. 1 1 plus is done. So 1 0 plus. That means if I am spawned right here, having the like at t equal to 0 in positive direction, then at t equal to 0 it is red light, so I'll flip towards here. Okay. Then at t equal to 1 I'm here, at t equal to 0 I'm here, at t equal to 1 I'm here, right? So from 1 0 t I have reached here at t equal to 1. That means I have reached to, sorry, from 1 0 plus I have reached to 0 1 negative. Like I have reached this cell, so cell 0 at time t equal to 1 and in the negative direction, right? So this state depends on this state. Okay. Now if I'm at here, what about this answer? So if I am at 1, if I am at 0, like 0th light bulb at t equal to 1, then it is red. So I'll flip it, and again I'll go, so 0 1 and 0. So again I am at this 1 at time 0 in plus direction. So basically the state 1 0 plus. So from this 0 1 minus, I have again gone to this 1 0 plus. So you can see we have a cycle here. So definitely answer is no, but we don't know about that. Like this is our graph. Okay, so these 5 states, and there are 3 more states which you can figure it out. So we have 1 1 minus, we have 0 0 minus, and we have um, 1 0 minus. So you can simply just find out that what is their condition. Like 1 1 minus means that you are spawned at, okay, I'll erase this to make it more cleaner. Why isn't it working? Yeah, so if we have Yeah, here I have a light bulb at 1 and light bulb at 0. So this one will show red at 1 and this one will show red at t equal to 0. So 1 1 minus means I am spawned at this one at t equal to 1 having negative direction. Okay. So um, here the light is green at t equal to 1. So I'll continue. So t equal to 0, t equal to 1, t equal to 0. So I have reached here at t equal to 0, right? So from 1 1 minus I can reach to 0 0 minus. Okay. And what about the 0 0 minus? This 0 0 minus is actually a base case, because if I am at here, if I am here at t equal to 0 and the signal is green, then I can simply like go here. If I am already facing in the negative direction, I can simply go out. So this is a base case. So I'll mark it as green. Okay. And then we have 1 0 minus. What is 1 0 minus? 1 0 minus means we have been spawned at the second one. We have been spawned at t equal to 0 on this vertex having the negative direction. Okay, so since t equal to 0, the light bulb is red. So we'll flip the direction and we'll just go out of the strip. So this is also a base case. So this is also, again, it is not working. Yeah, so this is also a base case. All right. Now what I can just do, like I have these four base cases, right? So in my graph, these two vertices can reach a base case, right? Like if you can see that this vertex has an arrow towards the base case, so I can mark this as well. I can just mark this one as green as well. Okay, and also this node also has an edge towards a green one, so I'll mark this one as well. So to implement this in code, we can just reverse the edges and start a BFS from all of these base cases, right? And whatever nodes are marked green, we can just say that at those points the answer is 1, otherwise the answer is 0. So we have found out the answer for all of the positions which have a light bulb in them, right? But here in our queries, we don't actually have a light bulb. Like it isn't guaranteed that wherever we are dropped, there's a light bulb there. So how do we actually solve it um, without that condition? So like let's say you know that the answer to these two cells are this. Like we just figured out that what is the answer for these two cells, because there were light bulbs here. For every time, what is the answer to these two cells for both directions? We know. So let's say we have been dropped right here. We were dropped right here at t equal to 0, right? So what we will do, we will just check that what is the next light bulb, right? And when we reach there, what will the time be? So here, if we reach, the time will again be 0 if k is equal to 2. So from 0, we go to 1 and then again 0. So time will be 0 when we reach here and we'll be at this direction. So we'll just check that what is the answer to this. Is it yes or no? Right? And that's how you can answer the query. And you can find out that what is the next light bulb in our street after our position using binary search. Just lower bound function you can use to find this, right? And that is the entire DP approach of this. So it is DP only, but the dependencies are cyclic also in this case. So in that case, you will have to do it differently. Like think of it as a graph and just mark all the states that can reach the base case as green. So mark this as green and this one also as green. So all the 6 nodes as green, like this one, this one, this one, and these 3, they all have answer as yes, and these 2 have answer as no. All right. So this is the logic right here. So is it clear, everyone? I don't see any comments here. So is this because you did not get anything, or is it because some bug is there, or is it because you got everything, so you have no doubts? So guys, just let me know that did you all get it? Okay, it is a there's a bug here. Oh shit. I will see my phone. Why is this not updating? I just watch YouTube. Okay, so why not DP? I thought DP K1 I direction means whether we can exit if we are at node at time K1. Yeah, that's what we are doing. कुछ कुछ div to A नहीं होते क्या करूँ? I'll address that in just a few minutes after I discuss the code. So the code for this I'll show you. Okay, so I'll show the code for this one. So actually the code is what I've done here is that normally what you would do is you would make a vector, a 3D vector, right? Like if you want to store the answer to all the states, okay, then what would you do? You would just take the input of n and k and c in n and k, and you would just store that. Like what I am storing here is that what is the next state to the one I am in right now. Okay, like let's say for this state right here, let's say for this state at t equal to 0 and positive direction, I am storing that what is the next state and at what time will I reach there. So I am just storing three values for, like, essentially what you would do is you would do a vector 3D vector, right? Vector of int dp, where dp of I j k, or like let's say I j and direction, this would just um, store your state, right? Like I is your index of the like light, then j is your time mod k, and direction is either 0 or 1 depending on positive or negative, right? You would do this, but instead what I did, and yeah, vector of not vector of int, but pair of int comma int, because you need to store three values, right? Because your one state is defined by three different values. So if you are storing that for every state, what's the next state, then you would need to store three values, right? So normally you would do something like this. You would do something like 3D vector which stores three values, right? So dp of ij direction would store three values which has the next ij and direction. But instead of that, this is very ugly. This is very ugly and inefficient. So instead of that, I just made a struct. Like what I did, I just made a struct called node. This node, it just stores the ij and direction in itself. So I just made a vector of nodes. I just made a vector of node which will store all of these parameters. Okay, and it is only a 1D vector because I have just made it in linear fashion. Like it is, instead of this 3D vector, I have just flattened it out into a one long vector, like dp of ij direction. So ij direction y, like this I can have n different values, this j can have k different values, and this dir can have two different values. So basically the size is 2 into n into k. So this 3D array has size 2 into n into k. So instead of that, I just made a vector of node having the size 2 into n into k, right? Okay, and like it is only a 1D vector. So essentially, if you have seen that you can actually represent a 2D vector as a 1D vector. Like let's say you have a 2D vector, let's say m of size 3 by 3. Then essentially what you would do is, let's say you have this 3D vector, right? So instead of storing the elements like this, you can just store 9 elements like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So let's say if you have 1 comma 0 right here, so it would be third element, right? Like 0, 1, 2, and 3. So it is a third element in this 1D vector. So if you have I comma j, if you have I comma j, then your dp of I comma j in 1D, it would be just dp of I into the number of columns I into m plus j. Like I did this, but you don't need to do that. It is optional. I mean, I just did this because this seemed very ugly to me, so I just did using like this. But actually, it is not required at all. In fact, the code that I'll send you, I'll change it. Okay, I'll just make a vector of node, and I'll make it a 3D vector for you. Okay, but here just bear with me. Like just forget this syntax. What I'm doing here, next of node of ij.id is equal to node of this one. Like just ignore this. Just look at this. Like I'll show you. Like okay, now let's go to the code. Now we'll just go to the code and I'll tell you along the way. So what I'm doing here is take the input of n comma k and take the input of the positions and the offsets. Offset means like at what time does the light bulb go off. All right. Then we have a vector of node, or basically we have something like this. Like we have something like a 3D vector which will store your answers. 3D vector, right? And here what I'm doing, I'm iterating over all the possible states. So for int I equal to 0 as I less than I plus plus. So next state of I j dir is basically I plus 1, because if I am at positive direction, like if direction equal to 0 and this, like either if direction equal to 0 or my O of I, that means is equal to j, which means that currently if it is red light or if it is green light and I'm in positive direction, so either of these two, if that is so, then I'll move in the positive direction. So the next value, like the next of ij direction, will be I plus 1, the I plus 1th light bulb, and the time will be the current time plus the distance between these two, a of I plus 1 minus a of I modulo k, right? And direction is 0, like direction is positive direction. So 0 is positive and 1 is negative. 1 is negative. Okay. So the next state of I comma j comma direction is I plus 1 comma j plus distance mod k comma 0. If we don't, like if we go to positive direction, and if we go to negative direction, then for I, our state will be I minus 1. Like next of I j dir will be I minus 1 comma this distance plus j mod k comma 1. 1 means negative direction, right? So in this loop what we have done is we have defined the next states for all of the nodes. Like for all of the states we have defined the next state, and just for the base cases it will be minus 1 minus 1 minus 1. Like if it is a base case, that is from there we can directly go outside, then it will be minus 1, like the default value, right? Then what I have is I reverse the edges. So I have this adjacency list. So what I'm doing is adjacency of next of I dot pushback I. So for all I'm doing this. Okay. And then I'm just running this BFS from multiple BFS from all the base cases. So okay, I iterate over all of these states, and if the current state is a base case, that is, if the next of ID is -1, then this ID is a base case. So I'll push this into my queue, and answer equal to true. Like I have this answer vector which will initialize to false. So the base cases are true, and I'll run a BFS from all of the base cases, and I'll just mark all of them as true, right? And then I handle the queries. So in the queries, what I have is int pos c in pos, it equals to lower bound of a plus 1 pos. So I just find the next light bulb to it, and if it is it dot end, that means there is no light bulb after this. Then it will print yes, because we are already at the end. Otherwise, we'll just find the answer of the next one. Like it minus a is the index of that, right? Iterator returns the iterator. So if I want to get the index, I'll do it minus a. So the answer of index comma distance mod k comma 0, because we are in the positive direction. So if that answer is true, then I'll print yes. Otherwise, I'll print no. So I hope that overview is clear of the code, what I am doing here. The syntax might not be clear because I have used something like constructors and the structs, but you don't need that. I just did it out of fun. So like I'll just share the code without these things. All right. I'll make a 3D vector of nodes. Okay, so this was the code. So any doubts, anyone? Any doubts? If you have, you can ask. Okay, let's first take the doubts related to the problem D. Like in this problem, does anyone have a doubt? In this problem only. Um, this D problem. Do you have any doubt? Okay, so I think there is no doubt regarding the D problem. So yeah, now I'll take. Okay, if, 5 is saying D1 can be solved just by simulation. Um, okay, yeah, that is true, but you would have to find the cycles as well. Like you have to detect that if you have come to this state previously, then you should not come here again, right? But yeah, this is true. Like you could solve it in O of n into m into q, n into k into q. Like you can just simulate the entire process and solve it in O of n into k into q. Okay, but what I solved it in O of n into k plus q, right? But yeah, okay. Anyways, so अभी asking कुछ कुछ div to a नहीं होते तो क्या करूँ? So like abhi, if you can solve the BNC of div 2 but a nahi ho pa raha, that means that you have the skill, but it's just that us din that day the div 2 was thoda tough, or like it was something like striking, like it did not strike you, but the problem is not that hard. So you can, yeah, you can try BNC. Like if you are able to solve BNC in other div 2s, then you can try BNC and skip that a for now. But like if you are not able to solve the like, let's say regularly you are able to solve only A and not BC, and in that contest you can solve only, like, not even solve A, then you should try A only, because there are very low chances that you can solve B and C in that contest. So you should keep trying A. But sometimes it might happen that um, you can solve B and C but not A. So in that case, you will just focus on A. All right. And like to improve that, you can just practice. Like if you can, basically the only thing that I advise you all is that whatever ratings you are not able to do, just solve those problems. Like if you are comfortable till 1200, then solve 1300. Okay. And comfortable means that you can solve like 70 to 80% of questions regularly. All right. So if you can do that, then just focus on one rating higher. So just go on this problem set, CF problem set, and add this filter, add this difficulty filter, and just solve them. There is no easy way to this. Just solve it. Okay. Solving only diff 2A of the past 120 contest will help in that. See, diff 2A, I won't recommend that. Like, I would recommend you to solve rating wise, because sometimes diff 2A might be easier, sometimes it might be harder. But what you can do is just solve the same difficulty. Like, whatever you are able to solve, just solve one level above that. That is my only thing that I would advise. Okay, fire tune, C2 ladders. Actually, I do not remember this. How, like, when I told you this, actually, like, I haven't actually done C2 ladders myself. Like, what I'm saying is, I have never done this C2 ladders, so I don't know why you think. Uh, yeah, like as you can see, I have not solved this ladder, so I cannot comment on the quality of these problems. But my point is that as long as you are being stimulated by the problems, like as long as the problems are not too easy for you and not too hard for you as well, like as long as you are solving right rating, it doesn't matter like whether you solve it from C to ladder or solve it from problem set rating by rating, like from here, doesn't matter actually. So you can solve from anywhere where you like, whatever you like. Okay. What I used, actually, to be honest, I just did randomized problems only. Like as you can see that for quite some time I was stuck at CM. Okay, like I show you. As you can see here, I was stuck at CM for a very long time, from this point to this point, right? So from this July 2024 to June 2025 or May 2025, let's say May June 2025, I was stuck at CM. So what I did, as you can see that at this point, my growth started to happen. Like at this point, I started to grow. Until this point, I was quite stagnant only. But from this point, I started to grow. So how did that happen? Actually, I asked one of my seniors that, "Sir, why am I so stagnant? And like, how do I improve?" So all he said was, "I have not practiced many questions of these ratings." Like he looked at my profile and he saw that I have only solved till 1900. Like these problems of 2000, 2100, 2200, 2300, they were very less of mine solved. That's so he said that that is why your rating is not increasing beyond that level. So if you want to increase the rating that beyond that level, you have to solve these problems. So what I did was I made, like, I just went to this CP, like CF problem randomizer. Like you can see, this is a website which will take a rating for you, and it will give you the question of that rating, randomized problems of that rating, So I just took like I think 28 problems randomly and made a contest on VJudge. Like this is a site where you can make contests, right? So I just made a contest here of 1 month and I just kept solving. Like as you can see, this contest I did. So I made this, and this all has this has all problems from the rating of 21 to 2300. So I just put that rating right here, this rating, and I just click this button 28 times, and I just chose these problems and I add those here. And this is not this is not very useful. It is just for motivation. Like when I see that I have solved these many problems of these ratings, I'll be happy. So this is why I made it, and solved these. So as you can see, I solved these many problems of rating more than 2100, and that's why I am that's how I improved from this range to 2100. So if you are stuck at some rating, and if you are not able to solve problems of some rating, then you should practice that rating more, and it will definitely help. I did not follow any resource, like I did not follow any ladders or anything. I just used this website to get random problems and just made this vjudge. Like this is not very useful, but you can do it if you want, right? So yeah, anything else? It is about practicing many problems and on various patterns and types. Yes. कंस्ट्रक्टिव के टिप्स दो, क्योंकि मुझसे ये हो जाते हैं पर 1200 के कंस्ट्रक्टिव नहीं होते. वेल इन दैट केस एक्चुअली ये दिक्कत मेरी भी है, मतलब कंस्ट्रक्टिव इज वेरी वीक फॉर मी. सो व्हाट यू कैन डू, अगेन ऐड टैग कंस्ट्रक्टिव्स, apply, and difficulty you can set to whatever you want. Like let's say 1200 के नहीं होते, तो 1200 से let's say 1600. So you will just select this and solve the problems. And for some reason I have solved these many, actually, because it shows in the order of recency. Like the problems which occurred in recent contests, they will be showed first. So since I give all the contests, the problems are right here and I have solved them. It is not like I have solved them alag se. These are all in contests only. But yeah, so just go to the difficulty, like add this tag, this difficulty, and also what you can do is just sort this by number of solves. Like you can click on here and sort it by number of solves. So it will give you the more solved problems first. And what you can simply do is scroll a bit down, because the problems which are like above here, they probably are not very tough. So you can skip them and you can just come down here and start solving from here. Or you can even go to page 2. You can go to page 2 and start solving from there. Start from here and just practice. Practice is the only option. Patterns जो भी होते होंगे, patterns, yeah, like there are some patterns which get repeated, but mostly they don't get repeated. But the main point of practice is that your thinking is being trained. Okay, like it is not to recognize the limited patterns there are. Like if something is repeated, then you solve it. That is not the point. The point is that your thinking will be like stimulated, and that's how your mind can improve. All right. Chat miss. Rohan is asking, I struggle at div 2a quite a lot. Currently at 942, but sometimes while solving, I'm able to approach with div 2c, but can't code it. Intuitions are correct. What rating range suggest? So, rating range ke liye, just try some problems of, like, let's say if you, see, intuition is nothing. Like, intuition aa jata hai, but code nahi hota, that is fine. Like, I don't care. As long as code nahi hota, you should solve those problems. Okay, like let's say 1200 हो जाता है, इंट्यूशन आ जाता है, लेकिन कोड नहीं होता, then solve 1200 only. Like don't go ahead just because you can solve, like just because you get the intuition. Okay, So you can basically, for the rating to determine, you can just find out that till what rating are you able to solve comfortably, and after that, like just one rating above that, you can start solving. Okay. Speed. Yes, I did not, like I did not actually comment on that. Like I could not solve D2 today, so I did not comment on that. Right. Like actually, I have some approach in my mind. Like what you can, like what one of my ideas is that, um, here what you are doing is you are just keeping all the true states and starting a before from them, this from them, right? So what you can simply do in D2, like I'm just guessing, like I'm not really sure about this, but you can observe that the states at which, like the time at which the signal is read, like let's say if we look at this signal, so time at which it is read, it is only very less. Like if we have k equals to 10 to the power 15, then the time for which this is read is just 1 in 10 to the power 15 times, right? So what you can try to do is that, like for the other times, it is green only, right? So definitely all of those states which have left direction and green, that is for which time is not equal to 1, they are all um, like in your base case, like they are all your base cases. So what you can simply do is, let's say you can reach this node, let's say from this node, then essentially what you want is that, um, you want that all of the cases except for t equal to 1 should be marked true. So all of the cases except for 1 minus 3 mod 10 to the power 5, or mod k, like because the distance is 3, right? So if you do 1 minus 3 mod k, like here, if t is not equal to 1, then here it cannot be minus 2 mod k. So if it is minus 2 mod k here, then if we go and take 3 steps and we reach here, we reach in minus 1, right? So essentially, you can just mark all of these vertices for which it is not minus 2 mod k as true. So instead of just marking, like actually, I don't have anything concrete right now, but my idea was something like, we were just marking states here which had a true, right? But what we can simply do is we can try to mark that except for this state, except for this time, except this time, I have a true at all other times. So you can similarly, like do something like this. Like this is my idea, but I don't have anything concrete right now. But you can try to think about it. Explain this question. You can rewind the video. Like I'm just explaining D2 only. I mean, I am not explaining this question because I did not solve it. I was just telling my idea. Like I don't have something concrete right now for D2. I just have an idea how we can solve it, but not really the entire solution. Look down. What? Graph for CP where to practice. For graphs, what you can do, you can like solve CSES. So in CSES, you can solve like till, I guess, till here you can solve. After that, it is pretty like advanced. Like basically, these are all different concepts. Like these all different problems are different algorithms of graph. So whatever you have studied, just solve that in CSES, and then again, I think you know what I'm going to say to you. Just go to this problem set, add tag, graph, graphs, apply, and rating if you want. You can apply here. Okay. Upsolve. Uh, I think I should solve ideally one question. Like it depends on the rating to be honest. Like if let's say for example one contest it went good. Like let's say for example this div 2 I solved 5 out of 7. So like I solved till A B C D and F1, and here E and F2 were of very high rating. So like E is of 2600 and F2 is of likely like 3000 or something. What is F2? It is loading right now. Yeah, so F2 is of 2800. So I definitely could not solve anything in this contest because I already solved till A, B, C, D, and F1. So actually, it just depends. I don't have any number of problems. It is just that if the problems are less than like my level, like I only solved till 2300. Okay, so if the questions are less than that level, I just try them. Like I should try them. Okay. At specialist, what should I do? I just answered that like practice, and I just told you the way to practice as well. Currently, 1500, and if you get expert, yeah, just practice problems having this rating of 1600. Just practice problems having 1600 rating, and you should be fine. Like 16 to 1700, I think you can solve. You can solve this, and yeah, you can even try out the CP sheet by TLE Eliminators. So there is this CP sheet. It has selected problems. Like as you can see, I have solved most of the syllabus. So you can try this as well. Like someone who was asking about where to solve problems, you can try from here as well. These are very nice quality. ABC in contest make specialist. I think it should make specialist because I mean, according to my experience, it should make specialist. In fact, when there was no cheating, it would make expert as well. Like as you can see, I used to do in Div 2 like three problems in Div 2, and I became expert using that. So if there were no cheaters, probably you would become expert as well. But since there's cheating going on so much, you cannot. At least I think you can give. You can become specialist. I think it could. Yeah, quick you can make you expert. Yeah, I think yeah, my speed was pretty much very fast, so that's why I became expert. Like here, if we see, okay, this one I didn't underperformed. Um, so this one, if you see, I solved three, and yeah, I solved them in 45 minutes. So it is pretty fast. Sorry, I can't do that right now. You can DM me. We can talk on chat. You can DM me on Codeforces. How to bring consistency? That is just your discipline, man. Like I cannot guide you with that. Like personally, I did CP because I enjoyed it, and not because of any internships or placements or something. So I can't really guide you that how you should um, have some discipline. I can't motivate you, to be honest. Like the motivation should come from inside. There is, I don't think there is a way for me to motivate you, except yeah, there is no way to for me to motivate you. But if you have, sorry, if you have discipline, then consistency will come. Anyways, so I think I'll take your leave now. uh Brother, I am only in second year right now, so I don't have this experience of interviews. And I hope I don't have, like, I hope I don't get to give fang interviews. Like, if I get quant, then of course I won't give fang interview. So I just hope I don't. So I hope I won't be able to answer a question in the future as well. For now also, of course, I cannot answer because I haven't given any interviews. uh, I mean, I don't have really anything to check. Like, you I can't really check anything, man. Like, ICPC, yeah. Like last year, I went till Asia West, I and my team. So this year, I will try for World Finals. I hope we can reach there. And my team is pretty strong. Team is pretty strong this time. So quant interviews are tough than Fang. Yeah, definitely, because their stipend and CTC is also much higher than Fang. Like, at least the quants which come at IIT Roorkee, they give like 5 lakhs per month as stipend. And those which come at IIT Bombay, they give even more. Like IMC, it comes only to IIT Bombay and IIT Madras. It gives, like, it is giving 25 lakhs for 2 months or something. So yeah, it is pretty high, and that's why it is very difficult than Fang. All right, let us just leave now. I'll see you guys next time. And if you all have any feedback for me, just don't hesitate to comment in the chat. Jane Street is OP. It is like, yeah, Jane Street is Hong Kong based, so it, of course, it gives much more. I think it is like 18 lakhs per month or something. But yeah, CTC is 4 CR and stipend is 18 lakhs or something. As far as I know, it might have increased as well. But the last time I saw, it was this much. Yeah, true. You can try. On YouTube, there are many things. There are many people who solve, who like give Jane Street puzzles. And in fact, you can solve, if you want, like if you like puzzles, then you can solve from this site as well. There are many puzzles here and they are very good. Like Jane Street types, they are probability puzzles basically. And you can try this website, Puzzled Quant, also. This is also a nice website to solve puzzles. But yeah, it is cool. Anyways, like 1.2 CR, I mean, in India, average, I guess, is 90 or 90 LPA to 1 CR, I guess. And that is CTC, like including taxes and non-cash benefits, like they give you like parties, food at office. So including all that, it is 1 CR. Yeah, CP is like kind of person only. It is CP is pretty IQ based. It takes thinking. That's why I actually liked it. Like in my first semester, I tried many things. I tried CTF, I tried CP. Like, no hate to CTF, but I liked CP more, and I liked it so much that I kept doing it for my entire 2 years. Yeah, it might be possible. It depends on company to company. But the quants which come to IITR, they give, I think, around once a year. Anyways, I will take your leave now. All right. So bye everyone. Have a nice day or have a nice night. Good night. NK Securities, that like gives, I think, 1.8 CR or something, as far as I know. Anyways, bye everyone.